area of a triangle using the sine ratio. First, we will look at some prior knowledge for finding the area of a triangle. So now let's do a question. Example 1. Find the area of the following compound shape. First, we will divide the shape into a rectangle and a triangle. Then we will break up the full height of the shape into the height of the rectangle and the height of the triangle. We see from the right of the rectangle that its height is 5 centimeters. Therefore, the height of the opposite side must be the same. Comparing the 5 centimeters then with the 9 centimeters, we can see that the height of the triangle must be 4 centimeters. Now, we can clearly see here that we have two shapes in this compound area. The only dimension we are missing is the width of the triangle. This will be the same as the width of the rectangle. Okay, so now the formula that we have from primary school is that the area of a rectangle equals length multiplied by width. We are going to advance that formula now. Instead of length multiplied by width, we are going to say base multiplied by the perpendicular height. So the 7 centimeters here is my base, and the 5 centimeters is my perpendicular height because I know it meets the base at a right angle. Now, the area of a triangle is actually half the area of a rectangle. So the formula we use for a triangle is half the base by the perpendicular height. Okay, and that's the one you have from primary school. Half of the base by the perpendicular height is half multiplied by the base multiplied by the perpendicular height. Now we are going to advance that formula so that you can read your log tables. The log tables are a great asset because you are permitted to have them during all your exams. So let's have a look. On page 9 of your log tables, we have the area of a triangle, and you can see the diagram here. On the diagram, it shows a base called A. You can see it's a little a, and a perpendicular height called h. So from now on, we will know our formula as the area of a triangle equals half multiplied by a multiplied by h. Now we know we can also represent this using brackets. So a half bracket, a end bracket, bracket h end bracket. Okay? And we know this can also be simply represented by putting the variables side by side. Now, in your log tables, capital A is always used to represent area. So you can see here is your formula for your area of a triangle. Capital A equals a half AH. So the area of a triangle equals half the base by the perpendicular height. So now if you look on the right hand side, what do I have for my question? I now have that the area of a rectangle is A equals AH, the base by the perpendicular height. The area of a triangle is half AH, half the base by the perpendicular height. And then for substitution, we'll be using brackets. So the area of a triangle will be a half times A times H using brackets. Okay, so to do the question then, we need to label the two shapes A and B. We will get the area of A and B separately, then add the areas to find the full area of our compound shape. So area A equals half AH. Now always write your formula as attempt marks are frequently awarded for it. So now sub in 7 for base A and sub in 4 for the perpendicular height H. Okay. Now remember that the brackets mean multiply, but if you like, you can use your calculator for this. Okay, so to put in the fraction, use your fraction button. 1, arrow down to the denominator, 2. Use your arrow to come out of the fraction, and then use your bracket, 7, end bracket, and then another bracket, 4, end bracket. And the calculator understands that these brackets mean multiply. So equals 14. So the area of the triangle A equals 14 centimeters squared. Remember, the units are centimeters and this is area, so centimeters squared. Okay, now the area of B equals AH. Okay, so the base by the perpendicular height. So we're going to sub in 7 for the base A and sub in 5 for the perpendicular height H. Now remember that brackets mean multiply, so this reads 7 multiplied by 5, and we know the answer is 35. And remember its area, so centimeters squared. So the area of B is 35 centimeters squared. So now we take the area of A, which equals 14 centimeters squared, and the area of B, which is 35 centimeters squared, and add them together. So the area of my compound shape equals 14 centimeters squared plus 35 centimeters squared equals 49 centimeters squared. So now example 2. Find the area of the triangle ABC correct to 1 decimal place. So we have here a triangle where we know that the length of AC is 11, the length of BC is 12, and the measure of the angle ACB equals 34 degrees. But looking at our diagram, what do we not have? We don't have a perpendicular height that we can easily read. So what we're going to do is we're going to go back to the log tables on page 9. And we can see here from our diagram that we do have the option of the base by the perpendicular height. But if you don't have the perpendicular height, what we can do alternatively is we can look at two sides of the triangle and the angle in between those two sides. Essentially, we are going to use the sine of this right-angled triangle to find the perpendicular height that we are missing. So using my two sides with the angle C that's in between the two sides, I have a new formula for finding the area of a triangle. A half multiplied by the side A multiplied by the side B multiplied by the sine of C. Now it is most important about this formula that the angle must be the included angle. So that's the name we give the angle that lies in between the two sides, the included angle, and it must be that angle. Okay, so our formula for this question is the area of a triangle equals a half AB sine C, and we need two sides and the included angle. So if we look at our diagram, we have the side length 11, and then we have the side length 12, and then we have the included angle 34 degrees. So that's perfect. So write down your formula for your attempt marks. Now, if you want to know exactly what A, B, and C are for this formula, A is the side opposite the vertex A, B is the side opposite the vertex B, and C is the angle at the vertex C. So filling in our formula then, we have got a half multiplied by, then sub your 12 in for A, sub your 11 in for B, and sub 34 degrees in for C. Now, the triangle won't always be called ABC in a question. You need to tune your eyes to look for two sides and the included angle. So that's what you need to tune your eyes for. Okay? Also worth mentioning, it won't matter which side you sub in first because order does not matter when we multiply. So just look for your two sides and your included angle. So let's put this into the calculator. Okay, so use your fraction button to put in a half. So 1, down arrow 2. Use your arrow to come out of the fraction. Brackets 12, bracket, and then bracket 11, end bracket, and then just the sine of 34 degrees, end bracket on your angle, equals 36.9067. Check your question. they want us to leave the area correct to one decimal place, so that will be 36.9. So my area equals 36.9 units squared. Example 3. Find the area of the triangle DEF correct two decimal places. So we have here that the length of DE is 12.1 centimeters, the length of DF is 13 centimeters, and the measure of the angle EDF is 47 centimeters. So once again, we've no perpendicular height that we can easily read, so straight to the log tables to get our formula using two sides and the included angle. So our formula then is a half AB sine C. So on my diagram, I have 12.1 centimeters is one side, 13 centimeters is the other side, and then 47 degrees is my included angle. So write down your formula and then sub in your two sides and the included angle. So subbing in 12.1 and 13 and subbing in 47 degrees. So type this now into your calculator. So press my fraction button. So 1 down arrow, 2 arrow out. So that's a half times 12.1 end bracket times 13 end bracket by the sine of 47 degrees end bracket equals, so 57.5209. Check your question, it asks for the area correct two decimal places, so we will take 57.52. Okay, so the area then is 57.52 centimeters squared.